Today we're going to talk about multiplication and division of radicals. To multiply or divide radical expressions that have the same index, multiply or divide the radicands and simplify. I like to teach this, and I use the word belly buttons. And I always ask the students, what kind of belly buttons does everybody have? And everybody says, well, they have innies and outies. And that's basically how I teach this with the innies and outies. Innies means underneath the radical or the inside the radical. Outies are outside the radical. So you're basically going to multiply your innies and your outies, and you're going to simplify at the end. Note, if the indexes differ, converting to a fractional exponents will help. And I'll show you some of those too. Here are the steps to multiply and divide radicals. First, multiply or divide the coefficients. Those are your outies. That's the number outside the radical. Then multiply or divide your radicands. Those are your innies. That's the number inside the radical. Then you're going to simplify at the end. See the difference here? When you had to add and subtract radicals, you simplified first and tried to get them to match. Here, you can start multiplying or dividing right off the bat, and you simplify at the end. All right, let's look at some examples to practice. So I have the cube root of 2ab squared times the cube root of 16 8 to the fourth b. If you notice, my indexes are the same, so I can just start multiplying my innies and my outies right off the bat. On the outside, there's really just a 1 here, so we don't have to worry about it, so we're just going to multiply our innies. So I'm going to have the cube root of 16 times 2 is 32, a to the fifth, b cubed. So I'm done. When I'm finished multiplying, then I try to simplify if possible. So here you're going to break it down. So I have 2 times 16, and you can keep going right off the bat. And I've got here 4 times 4, and then here I'm going to have a couple 2's and another couple 2's. So I can simplify that. And then I need to have groups of 3 here and groups of 3 here. So in order to simplify that, I need 3 of something. So here I have 3 2's right here, so I can have a 2 come out. I have a couple 2's left over, so they're going to stay inside. Now I have an a to the fifth, so a group of 3 can come out, and a b, because that group can come out. What's left inside? Well, I have the cube root of, inside will be left 4a squared. So I have 2ab, the cube root of 4a squared. Okay, let's practice some more. I put a division one because they work the same way. If they write the division this way, go ahead and put it on top of each other just like this with a numerator and denominator. It makes it much easier. So I have 8 radical 45x to the fifth divided by 2 radical 5x. So again, my indexes are exactly the same, so I can go right off the bat and start dividing my innies and my outies. So 8 divided by 2 is 4. Radical 45 divided by 5 is 9. X to the fifth divided by x to the first power is x to the fourth. Now, I try to simplify that. Well, this is a perfect square, so that can come out as a 3. This is a perfect square. That can come out as an x squared because I have 2 groups of 2. So I actually end up having 12x squared is my answer, simplified. That makes it a lot nicer. Okay, let's look at this right here. Now I have 3 radical 2 multiplied by a binomial 4 radical 6 minus 7. Now this you're going to do the same way. You're going to use a distributive property, but make sure you multiply your innies with your innies, your outies with your outies, and you're going to do the same with this. So I'm going to end up with 12 radical 12, because 3 times 4 is 12, 2 times 6 is 12, minus, now this is an outie, the 7, so it only can be multiplied by the 3, so that's going to be 21 radical 2. Now, I have to simplify this at all possible, and I know I can with the 12. That breaks down to 4 times 3. And you can keep going, but a lot of you know that 4 is a perfect square, so that can come out as a 2. So this is 24 radical 3 minus 21 radical 2. And since my radicands do not match, that's as far as I can go. Okay, we have 3 more problems to do together, so let's look at this. All right, now I have 2 binomials multiplied with each other. Well, this is the same as if you did any other 2 binomials. You're going to multiply this 2 with the 3 first, and this 2 with this radical 3 next. And it's actually a negative radical 3. And then you got to remember what's innies and outies and outies. So 2 times 3 is 6. 2 times a negative radical 3 is negative 2 radical 3. Now I'm going to multiply the radical 5 times that by the 3. So I have radical 5 times 3, but that's an outie, that's an innie. So that's going to be plus 3 radical 5. And then I have 2 innies multiplied together, radical 5 times a negative radical 3. So it's minus radical 15. And these don't match. My radicands don't match, so I can't combine and I can't simplify anymore. I have a 6 and 15. It stays the way it is. And that's as far as we can go. So my answer is 6 minus 2 radical 3 plus 3 radical 5 minus 15. Now, I have a division 1 here, and I kind of started it a little bit to show you how you need to break it down. But I have a binomial here. I have 8 cube roots of 12 plus 20 cube roots of 16, all divided by 2 cube roots of 4, which I have a monomial. So really, you have to divide that term and that term by the 2 cube roots of 4. So what I would suggest is you break it apart like this. Take the first term divided by that, the second term divided by that, and then do each one. It's a lot easier. So if I divide my outies, 8 divided by 2 is 4. 12 divided by 4 is 3, so that's cube roots of 3. Plus 20 divided by 2 is 10. And cube roots of 16 divided by 4 is 4. And that's as far as we can go. But it makes it easier if you can split it apart. And the last one I have to show you are 2 binomials again. And I put some coefficients in front of the radicals, this one, just so you'll see how that works. So you're still going to use a distributive property. So I have 2 radical 5 plus 3 times 2 radical 5 minus 3. So let's start. This is going to be 4 radical 25. That's 2 times 2 is 4. Radical 5 times radical 5 is 25. Then you're going to multiply here by minus 6 radical 5. Go ahead and do this. Plus 6 radical 5. So you have 3 times 2 radical 5. And then, of course, the 3 times the negative 3 is minus 9. And if you'll notice what we have here, so this is kind of fun. This is the exact same thing, but the signs are different. So you should see that's the difference of, the difference will cancel out the middle term. So if you look at it, these cancel out. I have a negative 6 radical 5 and a 6 radical 5. So they can cancel out. Radical 25 turns to a 5. So 4 times 5 is 20. And I have 20 minus 9. So this whole thing comes out to be 11. Looks a lot nicer than what we started with.